Okay, here we go. So this will be our third and final of the big rules of exponents. Tomorrow we'll do a little quiz over these, and the reason why I want us to keep expanding out to figure out these rules is because if you get on your quiz tomorrow or on your test, probably next week we're looking at, and you blank out, oh shoot, is this when I add exponents? Oh shoot, is this when I subtract them? I don't remember the rule, I don't remember the shortcut. If you don't remember the rule or shortcut, you can always expand it out. Okay, if you don't remember the rule or shortcut, or you just need to verify it a little bit, you can always expand it out. Okay, so this one looks a little different though, because it's called raising a power to a power. So notice, remember, a power is base and exponent together. So 10 to the second power this is one power, and then we raise it to another one. Okay, so the first column, it's a little bit different. It says expand using the outer exponent. The outer exponent is a 3. So I'm going to write 10 to the second power 3 times, because the outer exponent is a 3. There we go. Because that outer exponent, is a 3. Let me try that again. That didn't stay there when I blew it up a little bit.
You should be doing this with Mrs. Golly.
Should I do like this or?
Oh, I don't know why I'm not erasing now. Come on, work with me. And that should be there. My eraser's not working. I don't know why. So the outer exponent is a 3. So that means we have 10 to the second power 3 times. So 10 to the second power 3 times. So the outer exponent's a 3. So we're going to go 10 to the second 3 times. Now that next column, it says expand using the remaining exponents. So now instead of 10 to the second, I'm going to have 10 times 10. Instead of 10 to the second, 10 times 10. Instead of 10 to the second, 10 times 10. So we expanded using the outside exponent, which was a 3. So that 10 to the second, we wrote that 3 times. And then we expanded out using the exponents that were left. They were all 2s. So we did 10 times 10, 10 times 10, and 10 times 10. Now what we're used to doing. How many 10s do we have? 6. So 10 to the 6th. Let's do that next one together. I want to make sure we're okay with use the outer exponent, then use the inner exponent. I want to make sure we're okay with that, because I think when I did that first row, some of you are like, whoa, what just happened? So let's do that second row together also. Let me scroll a little bit. What the heck? I know, I'm not sure what's happening though with...
Everything just
It's just, yeah.
well, now it's disappearing.
I know, because I'm erasing it, because I don't know what it's doing. Okay, so the outer exponent on the second one is a 4. So that means I'm going to write what's inside the parentheses 4 times. So we have 2 to the second, 2 to the second, 2 to the second, and 2 to the second. The outside exponent's a 4. So I'm going to write what's inside the parentheses. I'm going to multiply it 4 times. However many times that outer exponent tells me to. And then expand using the inside one. So we've got 2 times 2, 2 times 2, 2 times 2, and 2 times 2. We have 8 2s So 2 to the 8.
Oh, it's multiplying.
So go ahead, guys, take a couple minutes. See what you can do with the rest of the table. And I know those bottom two, like Miss Callie, it's a fraction. Hey, that's okay. We're not going to treat it any different. I'm not asking you to do any computation with fractions. We just need to expand it out and figure out what's happening with the exponents. So let's take a minute, see what you can do on that table. And I'm going to fix mine up here. I'm not sure what's going on with my computer.
From the internet being performed.
Not sure what's happening. And I'll probably rewrite it and it'll still disappear on me again.
Never know about that.
No, I probably need to restart because I took it home. So it probably just needs to be restarted. All right, as I walked around, that third row was looking pretty good. I saw a lot of x to the third, x to the third, x to the third. Our outside exponent was a 3, so we write x to the third. We're going to multiply it 3 times. 9. Then on the inside, x to the third, x to the third, and x to the third. So we end up with x to the 9. Whoops, that looks like a 4, maybe a 9. There we go.
Sounds like a Y.
Okay. It did kind of look like a Y, you're right. Now, when we got to the fraction ones, though, I'm starting to see some crazy things on people's papers. The outside exponent is a 3. So whatever's inside those parentheses, how many times am I going to write it?
3.
Just 3. As I walked around, I saw some people, they were like getting rid of the fraction somehow. The fraction was gone, and they just had a bunch of A's and B's written. We're not going to change just because it's a fraction. So if you need to take a minute and fix yours, please fix it. I want these to be your notes. I want them to be your resource. I remember last week we pulled out a sheet before we took a quiz. We used it as a resource to refresh us. Well, if our resource isn't correct, it doesn't do us a lot of good. So we want to make sure these are for you as a resource. It's nothing I'm going to collect and give you 1,000,000 points for. It's for your resource. All right, now it says expand using the remaining exponents. Do we have any exponents left? Well, we do, but what are they? Yeah, they're all 1s, right? Well, so we just have an A and an A and an A in the top. And we have a B and a B and a B in the bottom, right? So how many A's do I have in the top? A to the what? Third. And in the bottom, we have B to the third also. Yeah, when we get to those fractions, again, guys, we're not going to do anything different. That wasn't anything different. So don't let fractions freak you out. I don't know where it happens at school in fractions. I'm not sure. I don't know if it's somewhere in middle school. I don't know if it's elementary school. I don't know where it happens. Middle school. That then all of a sudden we see a fraction. All of a sudden we're like, oh no, things are harder because it's a fraction. When it comes to exponents, things aren't going to change. Let's look at that last row. Outside exponent is a 3. Man, I really liked the number 3 when I did this activity. I don't know what I was doing there. Okay, so everything inside the parentheses, we're going to write 3 times. That doesn't change just because it's a fraction. That's okay. Don't let the fractions freak you out. Don't let the fractions freak you out. I didn't do anything different. What's inside those parentheses, I wrote it 3 times because that's what the outside exponent was. All right, now we do have to expand these, though. X squared is going to be x and x. Then we're going to have another x and x. Then we're going to have another x and x. So we have an x squared, and an x squared. Those are all my x squareds from the top. Then on the bottom, we got to expand out the y to the thirds. So y, and y. There's one of them. Y, and y. There's two. Y, and y. There's my 3. So here's a y to the third. Here's a y to the third. And here's a y to the third. There's a lot going on in that last one. But I didn't do anything different. The outside exponent was a 3, so I wrote was in the parentheses 3 times, nothing different. And then each of those, I expanded out. So x squared, x and x. Y to the third, y times y times y. Now we just have to total it up. How many x's up top? 6. So x to the 6th, y to the, what do we got? 9th, yeah. Y to the 9th. Now let's see if I scroll if things will stay with me. I don't know. All right, it's staying. Sweet. Okay, so part B. Take a minute. I know some of you are like, Miss Callie, I got part B already. Miss Callie, I caught onto the pattern after you did the first one. We've done this kind of activity a couple times, so I know you guys know what the end result we're going for is. What's the shortcut? So take a minute, write down in part B. It says, as you look through the examples in the table, come up with a method to simplify the problem without having to write the expanded form. What do you think it is? I have a couple people, they wrote some things down, and it's like, they wrote like 3 words and they've got it. So I'm not asking you for a book. What's the pattern? Take a minute and think about it. Take a minute and think about it. See what's happening. What are we thinking, guys?
Because I think the exponent looks different.
Yep, the exponents are different. How do we get that different exponent, though? What's our pattern? So last week, when we multiplied, we ended up adding exponents. When we divided, we subtracted the exponents. What do we think's going on today? So last week when we multiplied, we added the exponents. When we divided, we subtracted exponents. Now when we have a power raised to another power, so we've got an exponent in the parentheses and one outside. What's our shortcut, guys? Somebody out there, raise your hand, tell me, what's our shortcut? What's our shortcut? Carter, what's our shortcut? Yes, I don't think I could have said it better myself. Keep the base the same and multiply the exponents. I really like that explanation, guys. I'm liking it as I walk around. And I saw a lot of people write things about the base. That's super important. It's super important for me to know not only am I multiplying the exponents, but that base isn't going to change. If my base is a 2, it stays a 2. If my base is a 10, it stays a 10. And in part C, I know you guys are getting used to this. It's kind of our third activity in a row here that's pretty similar. Part C I always throw in there just to show you, here's why we like the shortcut. The ones we did in the table, those don't take too much work to expand out. That's not so bad. I can write y 9 times and figure out it's y to the 9th. But look at letter C, though. Holy cow. I don't want to write out x to the 120 times. Whew. And then break down each of those 20 x to the 100s by writing out x 100 times. Whew. That's a lot of work.
That'll take 3 hours.
And I know some are like, Miss Scala, I didn't grab my calculator today, so I'm not real sure on that one. So can somebody out there help me out? We're going to multiply. I'm just going to show it. What do we get? Colin, what do we get? 2,000. So you would end up, by the time you were done with that problem, you'd end up with 2,000 X's on your paper. Holy cow, you might be done at the end of the school day today. You guys have other stuff to do though, right? I have more stuff to do than write out 2,000 X's. So part D, let's sum it up. When raising a power to a power, and remember, by a power we mean the base with the exponent. So x to the 100, this is a power. So by raising a power to another power, Carter told us before we're going to keep the base and multiply, yep, the exponents. That's our pattern. That's our shortcut. So guys, those are our three big rules. One of our rules, we're going to add exponents. One we subtract, one we multiply. Okay, we're going to take a little break. And when we come back together, we're going to practice this new rule. Okay, we're going to practice this new rule when we come back. All right, guys, so we discovered our new rule. See if mine will load here. Come on. There we go. Blow it up a little bit here. Now, the one thing we didn't look at, though, I want to do the first couple of these with you. The one thing we didn't look at, if we look at question 1, what happens when there's a number, a coefficient in front of our variable? So what I want to do for number 1 is I want to expand it out so we can see what should happen with this 3. We didn't experience that in the activity, and I knew that. So I wanted to use number 1 on our sheet to take a look and see what that means. So if I expand it out, I'm going to use the 3 on the outside first. So 3a squared, 3a squared, and 3a squared. So I just took the outside exponent, that was 3, and I wrote what was inside the parentheses 3 times. Now, if I use the inside exponents, I'm going to have a 3a, a 3a times a, and a 3a times a. So I'm using our expanding so we can see what we do with that 3. When we did our activity, we did something like a squared to the 3rd power. But now we have to figure out what to do with that 3. So if I do a little bit of rearranging, let's put all the 3's together. 3 times 3 times 3. And then I have 6 a's. 1, 2, 3, 4, 5, 6. So we end up with, how many 3's do I have? 3 of them, right? Okay, so we have a 3 to the 3rd, and we have an a to the 6th. So notice it's not just 3a to the 6th. That 3 was also raised to the 3rd power. Because our last couple classes, we've been talking about this a lot. Something like the 3, it really has an exponent, but mathematicians are too lazy to write it. So that 3 really has a 1 for an exponent. So I need to multiply the exponent to the 3 and to the 2. So when we use our exponent rule, we have to be on the lookout for those exponents of 1. We have to be on the lookout for the exponents of 1. So we would have 3 to the 3rd, a to the 6th. Now I will have you guys in just a minute, I will have you grab your calculators, because we can simplify 3 to the third, and I want us to get some more practice putting exponents into our calculator. So 3 to the third, I'm going to help you out on this one. It would be 27, a to the 6th. So you can use the shortcut. You don't have to expand it out. But I wanted to expand it out to show you we're going to get 3 to the third power. I didn't just want to tell it to you, I wanted you to see it. That if we expand it out, we end up with 3 times 3 times 3. So when you look at your paper, I'll be honest, what I would do, I would put those little ones in. I would put those little ones in there. So you have to be sure that you multiply. You have to be sure that you're multiplying all the way through. And I do want you, if you get something like 2 to the 4th, I do want you to go ahead and use the calculator, and let's go ahead and simplify that. Most of us, when we took our exponent quiz, we were okay with exponents on the calculator, but a few of us were kind of struggling with that. So let's take a minute and let's see what we can do. Let's just go at the top 6. And then let's check together, make sure we're okay after the top 6. Guys, let's take a look at these top 6. And I want to make sure, I know I usually take volunteers to come up to the board, but I want to make sure that we're solid on these top 6. A lot of us got it. A lot of us were asking questions. I saw many more hands being raised, guys. That's awesome. But I know some of us are still kind of sitting back, and I think we get it, but we're just kind of sitting there hanging out. So I want to make sure that we have these top 6 okay, and then we'll move on to the bottom next 6. Okay. All right. So number 3, remember, and one thing I know I was showing a lot of you when I came around to help, that 3 has an exponent of 1. And a lot of you were remembering that. That was great. So we have to do 1 times 4 and 4 times 4. The 3 to the 4th, remember it's not 12. I know it's been a little bit since we put those in the calculator, but remember that means 3 times 3 times 3 times 3. So it's not 12. It is, what do we come up with there? Is that 81? Yeah. 81. And then the x to the 16th, I can't do anything else with that. I can't put x to the 16th in the calculator and come up with a number. So I'm stuck there. I'll be honest, guys, as I look at number 4, I've got that little 1 exponent by the 6. Putting those 1s in, they're really simple, and they save us a lot of mistakes. So we have 2 times 1, and we have 2 times 2. I put 6 to the 2nd in my calculator, and I get 36. And I put the b to the 4th right next to it. I know some of you, when you first started these, you were trying to expand everything out, which you can, but man, those shortcuts are so much quicker. All right, number 5. Again, on the 7, we've got a little 1. So 2 times 1 is 2. 4 times 2 is 8. 7 to the 2nd power is 49. Whoa, there we go. Then on the last one that I asked you to try was number 6. Number 6 can be a little tricky. If you look at mine up here, notice the 3 has a 1 exponent and so does the a. Some of us missed it on the a. So we have 3 to the 4th, a to the 4th, b to the 16th. Please make sure that you have a to the 4th on yours. A lot of us missed that 1 on the a. If you don't have an exponent, we saw this a couple classes ago, put a 1. Put a 1. So then 3 to the 4th power, we had that one earlier, it's 81. A to the 4th, B to the 16th. To finish us off today, guys, I want to see if we can get the next 6. You get the next 6, and you're done for the day. Okay, next 6, and we're done for the day.
Don't forget to add those ones in.
Yeah, don't forget to add the 1s. I'm going to go ahead and put them up here, and then I'll be around.
Do it. If you have questions, don't be afraid to raise your hand.
Glad you're here.